Good afternoon, everyone, and welcome to this session. We're nearing the end of the conference, so I know everyone's maybe feeling a little bit tired, but you won't be tired much longer because we've got a great discussion here with some great speakers that I'm really excited to be here with. I'm Justine Gauthier. I'm the General Counsel and Head of AI Governance at Mila, and I'm joined here today by Laila Ibrahim, the COO of Google DeepMind, and by Kohei Ito, the president of Keio University. And I'm very excited to be moderating this discussion on the legacy that we leave behind and how we can build and deploy AI for the benefit of future generations. And I think this is a really important topic because right now AI is moving so fast. It seems like every week, every day, there's something new that's happening, and it's easy to get caught up in the constant what's next. When's the next version of ChatGPT coming out? When's the next version of Gemini coming out? When will AI finally be able to do my laundry for me? Or, maybe that's just me. But all kidding aside, AI is going to have profound impacts on future generations way beyond our lifetimes. And I think it's important in this moment to take the time and think about how we want AI to impact future generations and how we don't want AI to impact future generations as well. We're going to be spending almost an hour together, so I'd like to start with a bit more of a personal question as a get to know each other. Can you each tell us why you got in the field that you are in? And what legacy do you wish you'll leave behind with the work that you've done and that you are doing right now? And maybe we'll start with Laila.
Hello, everyone. Thank you for joining us, and thank you, Justine, for that question. Jumping right into a big one. So the journey and the legacy I hope to leave. So I have been in the technology industry for over 30 years. I spent my first almost 2 decades working for Intel in the semiconductor space as the computing industry was growing. And it was really an interesting time because I got to see firsthand the work with trying to make the internet available worldwide, bring computing into countries, into consumers, businesses, et cetera, and the digital transformation. From there, I moved on to venture capital because everything I had done at Intel was very entrepreneurial. I had been like new technologies, new markets inside of a big company, and I had an opportunity to work in Silicon Valley with one of the leading venture capital firms that made the first investments in Google and Amazon. And I thought, this is a perfect chance to see how do entrepreneurs work. And I was blown away by the bold ideas the entrepreneurs had to imagine things and solutions to questions I didn't even know existed. And it was during the mobile and the local era and social media platform growth. So it was a very interesting time. A lot of lessons there as well that I think we can learn from as we embark on the AI journey. I went into one of the startup companies called Coursera as the first executive and really helped to build the organization to pre-IPO. And there I was able to combine the corporate experience, the engineering background that I had, along with the startup mentality. Also happened to co-found an education tech nonprofit along the way. So I was at a point in my career where I had seen this technology transformation across many industries. And I thought, I'm approaching 50. This time of my life is really critical. How am I going to make my mark on the history? I'm really wanting to take all of my experience and to make it really count at this point. So in 2018, I had an opportunity to meet DeepMind. And at the time, it was just around the time of the AlphaGo movie. Maybe some of you are familiar with this. It really struck me because I thought this has to be one of the most transformational technologies of our time. But it's not my background. But can I bring my decades of experience with technology into this time in history? I spent over 50 hours interviewing because I wanted to know about the opportunities and the risks, and to know that every night I could put my children to sleep knowing what mommy worked on. And so it was a very important decision for me. But I felt that if I can bring my experience from technology and also think about the risks, how to mitigate them, but also be bold in how we're pioneering this new field responsibly, that it would be a legacy worth building on for this last chapter of my corporate career. So that is how I got here, and that is why I feel like this moral obligation to be in the AI industry, and I've spent the past 6 years diligencing it, so it's quite an interesting time for me.
I don't have a variety of experience as Lila, but I studied physics at UC Berkeley, University of California at Berkeley, for my master's and PhD. I was on the team for searching dark matter, missing particles in the universe. We didn't find it successfully, but then after I graduated with PhD, I moved on to teach at Keio University, where I am. Then I realized that I have to start something interesting but also impactful. So in 1999, I started working on quantum computing. So I have been working on quantum computers for 25 years. And of course, everyone, especially the physics community, when I first started to work on it, everybody thought that it was a science fiction. So some people looked down on me, saying that you're working on something truly non-physics. But I had to figure out many physics leading to realization of quantum computer, which of course was very interesting and also helpful. In 2015, we were able to finally demonstrate silicon quantum computer operation, which was published in Nature. And that's when I realized that, wow, real quantum computer is here. Then we switched the field from hardware to the software, because 2015 was about 9 years ago. That was when all the American companies like IBM, Intel started to work on industrialization of quantum computers. So we just sort of left those big homeworks to the industry. Then we decided that if the industries are going to develop real quantum computers, we should be developing algorithms and software for such real quantum computers. Then once we started working on with IBM in 2018. As soon as we started working, we realized that in order to evaluate the performance of the quantum computer as a computer, we need to understand AI. And so we started working on AI. And as soon as we started working on AI, we see some challenges that AI was facing. That the AI machine consumed huge energy. Power consumption is very large. So we thought about applying quantum computer for AI, because quantum computer uses much less energy, much less power consumption. But at the same time, we also recognized that in a quantum world, we can also apply AI, deep learning, to quantum phenomena. And quantum phenomena can only be realized rigorously in the quantum computers, not in your computer, but in quantum computers only. So I think the legacy we want to leave is basically application of quantum computer to AI is something that we're trying to leave as a legacy right now.
Well, thank you for sharing that. I think that what you shared about back when you got into quantum, and a lot of people were doubting that what you worked on would ever work, AI research certainly went through that as well for a while there. And thank you for sharing all of this, because I think that, beyond the AI and the computers and the robots, it's important and it's comforting to be reminded that at the end of the day, there are humans behind all of this who want to have a positive contribution to the world with the work that they do. But with that said, we're going to jump straight into our topic, and it's no secret that, over the past 18 months, the attention around AI has completely skyrocketed. But beyond all the noise and the hype, I'd like to hear you both on your perspectives on why this moment that we're witnessing is important, and on how we can shape the AI ecosystem in a way that's going to foster beneficial developments and deployment of AI now, but for future generations as well.
I'm relatively new-ish, 6.5 years since I've joined Google DeepMind. And there has been a lot of this work has been happening behind the scenes. I think what's happened in the past 2 years is society has become more familiar, more aware of AI, even though it's been around us with recommendation engines, voice recognition, a lot of optimizations of products and data centers, et cetera. But this consumer awakening has really shifted the way that AI is now being talked about, the way that it's being developed, et cetera. And so I feel in some ways that we've been building towards this moment. So it may feel sudden, but there's been decades of work that has led up to it, which is a good thing. Since 2010, when DeepMind was founded, we've always tried to build the responsibility in from the start. So a lot of the work that we did was thinking both about the technological advancements as well as the socio-technical. What are the risks and the opportunities? What is the vocabulary and taxonomy around technologies like generative AI or even an AI assistant? So I feel comforted, again, having spent 6 years helping to build the organization, that this work has come to fruition now. What is important also is the involvement. It's no longer an academic issue, it's no longer a research, it's in products everywhere, and it's requiring a type of global collaboration that maybe no other technology has experienced in terms of academia, private sector, governments, working to ensure that this powerful technology is getting developed and deployed in a responsible way. So I think that's basically what has changed.
On that point, Kohei, would you say, obviously with all this attention around AI, as you're saying, a lot of students and researchers are interested in going into that field, going into AI. But what about scientists that are working and researchers that are working in other disciplines? I think historically, or up until recently, they might have been, or some of them might have been, a bit more reluctant to use AI, right? So how are you seeing that
except
change
for chemists,
as well?
right? Yes, I mean, practically every scientist or engineers are now working with AI, and senior professors or faculty members are also using AI because their students are using AI. So we're all learning from our students on how to use or how to adapt AI. And of course, faculty members have many things to say, and sometimes AI gives us wrong solution or misleading solutions or misleading results. But luckily, faculty members can tell. So there's this new kind of interaction happening between faculty members and students. Before emergence of Gen AI, it was much more of the one-way discussion, especially at the very beginning of research experience. When students join research group at the very beginning of the joining, it's as faculty members and others, senior members, teaching one way. But now, they can just come up with some kind of results right away, and so that there's this more discussions going on.
I do think we're seeing AI in the technical space, but I also want to highlight some really innovative uses of where we're seeing researchers use it in non-technical areas. We had a project called Project Ithaca, which was about discovering, or how should I say this, taking ancient texts and maybe there's parts of tablets that are missing and trying to fill it, like dating them, being able to understand the written language and fill in the gaps. So suddenly we have history and cultural students who are learning about the past in a way they haven't, using this AI as a tool. And we're working with universities across Europe on this. We're also seeing this applied to the scientific fields, as you mentioned in our short exchange here. One of the areas, again, outside of generative AI, so I think generative AI is important, but we also have to remember that it's just one part of a very broad field. And if I could give an example of something we call AlphaFold, which is a protein prediction advanced AI system. So it basically takes a string of amino acids and it predicts the 3D structure of a protein. What's important is that a protein is the basic building block of life. So you can understand what function the protein might have. Maybe if it's misfolded, it's giving you indication of what the problem or a disease might be. So we developed this AlphaFold AI system, and we made it all 200 million plus proteins known to humankind available in a database open to the scientific community to then build upon, to understand why some crops are more disease resistant than others, to explore new ways of dealing with industrial waste, to better understand human diseases in the global south that are neglected and not necessarily commercially viable. This is just one example of where, previously a university student needed to have maybe 4 to 5 years to study one single protein, access to this very expensive equipment and knowledge how to use it. So if you think about it, 250 million proteins, about 1 billion years of scientific work now available. So we like to call this science at digital speed. So I do think we're starting to see AI be used almost like a microscope or a telescope to help researchers and to help the world get more curious, to President Ito's point, get curious and spark conversation and discussion, and to explore and understand things in a different way maybe that we haven't before.
And on that point of research, Lila, to double click a little bit, DeepMind, since its creation, was very much rooted in, and is very much rooted in research in academia. Fast forward to now, DeepMind is now Google DeepMind. You're one of the largest private AI research centers in the world. But you're also much more integrated to Google's overall strategy, and I think you mentioned that earlier, right? We're not anymore just talking about research. This is really going into products now. So given this new context, I'd be curious to know, how important collaboration with academia is at Google DeepMind, which you mentioned, and if and how that has evolved, in the past couple of years.
So for those of you who may not be familiar, a quick history lesson. DeepMind was founded in 2010, acquired by Google in 2014. Last year, we became Google DeepMind, which was really the merging of two different Google AI labs coming together to try to advance the field more holistically and collaboratively. In fact, if you've heard the name Gemini, it actually comes from the combination of two teams, and that's why it's called Gemini, Google Brain and Google and DeepMind coming together for the first multimodal foundation model. Now, DeepMind has always done work for Google products, but you would not have known that unless you have an Android phone with adaptive battery technology, or you were paying attention to the Google data centers that were running 40% more efficiently, some of the voice work, et cetera. But now as part of Google DeepMind, we're driving all of the innovation that's going into Google products through our generative AI work. But we'd like to think that AI is not just about scaling the technology. There's still innovation that needs to happen, and that's why we've continued concerted effort around foundational research, doing a lot of work with academia and with other industry partners, as well as all of our work in AI for science and all of our societal impact work. So I would say, actually, the more advanced the field of AI gets, the more important collaboration is, because the technology gets developed and immediately, like once it's developed and released and deployed, it's available to billions of people instantaneously. So it's more important than ever that we have that type of collaboration early in the process so that we know as it gets deployed, it's actually maximizing the benefit.
So at Keio University Hospital, we have the center called Centenarian Centers. So we have biological data of 1,000 centenarians, 100 years and older. And among 1,000, 200 are supercentenarian, we call 105 and older. And we actually test their blood and also examine their stools and everything for the secret of longevity, a long life. And so, and it's truly a big data. We have DNA sequence and everything, genome and everything of this 1,000 centenarians. And it's, to a certain extent, to a certain point, we can find some, secrets or some special genome sequence that actually is, behind such centenarians. But after some, human sort of, exhausting analysis performed by a human being, we thought, and also we're using computers and everything, we finally got to the point that we need true expert in AI to further discover that it's related to longevity. So we called DeepMind, and that was then as soon as we started working with the DeepMind scientists, we start all these new discoveries again, because we didn't know how to utilize all these AI tools to the extent that DeepMind had. And also, of course, DeepMind developed all these new technologies like informers and so on. So we university working very closely with forefront companies like DeepMind is the key for new scientific discovery as well as for new development.
We're talking about the transition that kind of the collaborative research space is seeing. But as a segue, we're also in a great moment of transition in terms of the workplace and education. So we're going to switch pages a little bit. AI is going to transform the workplace. It already has. Which also means that our education system needs to be adapted, and people will need to develop new skills. And I can see that we have a lot of young, bright people in the room today. So my question for both of you would be twofold. So the first part is, what are the necessary skills that a young person should be thinking of having to succeed in tomorrow's AI-driven economy? And the second part of the question is how we as the people and organizations that are working on this technology contribute to efforts around AI education and literacy. Kohei, maybe we'll give that one to you first.
So AI will transform education quite dramatically. Let's say new student to college with very, let's say limited knowledge of statistics. Even these students don't know anything about statistics. We can give away homework, like with the data and everything. We can just give away homework, like analyze and make it visualize and conclude what this data will tell you, because they can just take those data into generative AI and ask generative AI what kind of statistical method is appropriate for this particular analysis, and they can actually apply such analysis, even using Gen AI, and make the results in a very fancy visual manner. So without any knowledge, just with the skills of how to use Gen AI, they can actually generate results. And of course, students don't know whether the results they obtain is an appropriate one or not. But they can just like if you're a tennis player, you have to practice hard to play tennis. But nowadays you can just play game of tennis first, and then you can practice forehand, backhand, service, and so on, just like that. We can ask students to do the game first, and then step back and say, look, you use the statistical method, but you need to understand how this statistical method works. So we teach them basic math to make them understand what kind of statistical method they use, and what are the other options of the statistical analysis, and so on and so on. And this is not this kind of learning habit applies to every field. Let's say in Japan, we don't have the law to evaluate the war criminal, for example. But if we need to establish a law for to prevent war crime, then students can ask ChatGPT, how do we, make law against war crime, and then they can get results. But in order to really understand the results, you have to know the criminal law, you have to know the international law, you even have to know the constitution that actually talks about dignity of the human being and so on. So once they try all these sort of applied problem with AI, they understand the importance of each element in law, so that when we actually go ask them to study basics of the criminal law or international law and so on, they were much more motivated. They understand the reason or meaning or reason of why they need to understand each element, because they try some real application at the very beginning. Then once you go through all these basic studies, then you can again come back to the same problem of establishing the war criminal law, but now he or she has the knowledge so that they can actually come up with much better, and also the solution that the student, he or she knows, or actually he or she creates by himself, even when he uses AI. So I think the AI will change the education quite dramatically.
I think this is really interesting, and as someone who went to law school, what I'm hearing is I would still have needed to go to law school, but more seriously, I'm really interested in this point, so maybe double click on it, and curious to hear Lila's thoughts too. Because with AI, I think a lot of people are saying, no, actually, you won't need to study laws anymore, or whatever field. You won't need to go and study the actual knowledge base, and it's all going to be about soft skills, right? Collaboration, communication, and kind of human interpersonal skills. So what I'm hearing from you, President Ito, is maybe there is some truth to that, but you're still going to have the knowledge base. Lila, what are your thoughts on that?
First of all, I want to say that I do think the skills, what you called soft skills of kind of the curiosity, working with other human, bringing the human aspect to it, I think we've talked a lot about. I actually like to call those power skills, because I think those are the ones really that set you up to be the most empowered, to be the most powerful that you can be. And I think they were important 21st century skills at the turn of the century, not too long ago. I think they're increasingly important now as technology continues to advance. When I'm very passionate, my background, I have a lot of experience in technology and education dating over 20 years, primarily in the primary school education. And what I'm excited about is the fact that the technology can meet the student with where they're at in their learning journey. So I'm going to give you a very personal example. I have twins, and so I have a natural A/B test in my household. One daughter is a traditional learner. She can read and memorize and understands what the teacher is asking and can deliver exactly to that. My other twin grew up in the same household with the same parent, is completely different. I cannot figure out how to help this daughter understand and navigate current curriculum. And I'm very fortunate. I can afford a tutor. In fact, I can afford a tutor for one daughter who's very different than the tutor for the other daughter. But I am very, very privileged. And I don't have, when you think about people who may not have access to that as a resource, a tutor, or to a school that can adjust to the two different learning styles. So when I think about AI, I think about how both daughters can feel completely empowered in their lesson. They can find ways to, without being embarrassed, without being judged, to ask the questions, to be able to take a picture of a math problem, to show their work, and for the AI tutor, to be able to say, go check this step. This is where we think you've gone wrong, where you've missed it. Here's where you can go back to learn about it. So suddenly, the confidence, I've seen this with in my own small household, but as an example. So when I think about AI as a tool, I think that this is really what's going to happen. Imagine students have their own tutor to help with their learning journey in a way that works for them. And imagine the teacher now, instead of grading papers or trying to do the lesson plan, can now be freed to actually facilitate the learning journey in a more bespoke way for the learners. So we'd like to think of it as like a teaching assistant for every teacher and a tutor for every learner. And to me, this is really, it starts at a young age, but I could use a tutor right now for a lot of things. So I think there's something about this lifelong journey of learning. And I think that AI has a potential to really transform how we do this. But to be transformational, we have to be very responsible in how we're developing the technology, how we're deploying it, and how we're enabling people to use it properly.
All right, I see that we only have a couple of minutes left. So as we wrap up, I think I'd like to go back to where we started and also end on a bit more of a personal note and know what is the one thing, in all the opportunities that AI brings, what is the one thing that excites you the most, and what are your hopes for the future generation?
Well, I'm always a futuristic person, so I'm very excited about joint research between quantum and AI. So this is my personal interest. But just in general, I think that I started off as a semiconductor engineer. So now data center development and also quantum development and AI development all together, we feel very responsible for this technology's future because the resources of the Earth is rather limited. So we really have to think about the healthy development of this technology because it's so powerful.
Actually, I'm quite similar. I think about one of the biggest challenges, this is why I came into this field in the first place, of what are the big societal challenges and how can we use AI to help us understand those and unlock potential solutions. So if I think of sustainability and the climate crisis, we can optimize existing systems with AI in ways that we have never been able to do before. We can build better models to help with prediction, to help with prediction. The third thing we can do is unlock new solutions. We've been doing some work in Europe around plasma control for fusion. So when you start applying those three categories to the challenge of the climate crisis, all of a sudden we can maybe imagine a variety of paths. And I think it is going to take, I think there is no silver bullet in all of this. And so how can we use AI to help us understand problems and solutions so that the next generation can take that and use it as a step forward? What about you, Justine? Are you going to share yours?
Yes, I can share mine. I mean, I'm similarly going to echo your thoughts. I'm really excited about AI for science. I think it is the path to tackling some of the most complex challenges that we face, whether that be like healthcare and finding new drugs to tackling things like climate change. And my hope for the future, for me, it kind of comes back, and I think President Ito, you also talked about this during our session, curiosity. You know, curiosity is kind of what led me to this field in the first place, and I just hope that now that we have all these tools at our disposal that can kind of give us all the knowledge, this only makes us more curious and not less curious, right? So this wraps up our session. I will be sticking around here on the next session on AI ethics. So if you're interested in that topic, please stick around. But I want to thank you both so much for participating in this discussion, and we'll see you back all here shortly. Thank you.